content type as a feature. We have a balance of all the content types. In online metrics, A/B testing is used. Precision is about our model being correct, and recall is about our model not missing some good media. We are going to need some storage for the embeddings as well. Multi-stage architecture. We also have modularity. Why? Because there are two different models. The edge case essentially is the cold start problem. Horizontally scalable, it has high write throughput, and it would be a great fit over here. Netflix recommendation system. We are going to be approaching this problem step by step, just like we should be approaching any machine learning system design problem. We'll get started with discussing the problem statement. We'll talk about the functional and the non-functional requirements. Then we'll talk about the evaluation metrics, basically how we are going to judge the performance of our recommendation system. Then we'll discuss capacity estimation. We'll move on to data collection. Then we'll discuss the entire general system architecture, and then we'll discuss about the model in a lot of detail. Please note that in any system design, your focus should be on understanding the thought process and the pros and cons of different solutions that are possible, and that will be the effort in this video. Also note that just like in any other video, I have divided everything properly into the timestamps, and the notes and the design is available in the description. Let's get started. Before we move ahead, I would like to ask you if you know that in our Educosys GenAI course, I didn't just cover the application side, but I also covered the basics of GenAI. So neural networks, RNNs, LSTMs, we literally wrote the transformer code, went through the white paper, went through the DeepSeek white paper. We have done so much. You have to check out the testimonials. Plus, if you're preparing for interviews, then I have courses on DSA, LLD, HLD. We have courses on C++. There is so much. You have to check out the testimonials at least. Even the LinkedIn profiles of all our testimonials are added over there for credibility, right? So you should know that if you like my teaching style, I love teaching over there. We are building a great community, and so many people are already part of it. At least check out the details in the description. My first question over here is that what are we recommending? Are we recommending movies or just shows or just documentaries and so on? So these are the different categories of media that we have, right? Or different types of items that we are recommending, correct? So there are three approaches that I can think of. The first approach is that we are going to have a unified recommendation system, basically one recommendation system that can recommend any of these categories or types of items. So we can be recommending movies or shows or documentaries and so on. The benefit of this is going to be, obviously, it is going to be simpler, it is simple to design, simple to implement, plus we might be able to generalize better because we are going to have more data. But the problem over here is that we might have an imbalance of the different types of data, right? Because we might end up recommending only shows to a particular user if the user watches like only shows, or if another user watches only documentaries, we might end up recommending only documentaries and no movies. So this is one approach. The second approach is that we are going to have completely different recommendation systems for different categories, like one recommendation system for movies, one recommendation system for shows, another recommendation for documentaries, and so on. So this is obviously like it needs more engineering because we need multiple recommendation systems, but this will help us make sure that there is a balance of each category, right? The third is obviously going to be the combination of these two approaches, and that is what we are going to try to implement. Basically what we are going to do over here is keep things simple. We are going to be recommending any of these categories or items, or so whenever I say in the entire video, I'm going to be saying any item or any media, okay? So it can be movie or show or documentary or anything, basically any media or any item. And we are going to have content type as a feature. And we have to make sure that when we are recommending, we have a balance of all the content types. Also, interestingly over here, if we do a hybrid approach, we could also do something like this. Suppose a particular user is keen towards watching more movies compared to say shows or documentaries. Suppose the percentage is 80%, 10%, 10%, then we are going to recommend accordingly. Another user might be inclined to watching say 70, 20, 10%. So we are going to recommend accordingly. So here we might have better balance of the different types and categories, and we could do like this. What is the goal of our system? Once we recommend a particular media to our user, we want our user to engage with it. We want our user to interact with the system. Now, there are a couple of types of engagements that can happen by the user. Let's discuss them. One is a very explicit engagement. So the user is explicitly going to take some action. For example, the user might rate the media as very good or as very bad, basically 1 star, 5 star and so on. The user might like or dislike a particular media if that feature is there. The user might add the media to a list, like for example favorites or to be watched later, again if that feature is there. So these are very explicit actions that the user is taking. But what are the problems with this explicit engagement? Firstly, this explicit engagement is going to be very, very biased. Let's understand that with example. Suppose there is user A. User A might tend to give rating only if a particular media like a movie or a show is really good. So only if it is like 5-star content, they might rate it. They might not rate it if it is 1-star, 2-star, they might just move ahead. Versus user B might tend to definitely rate a media if it is like horrible, if it is pathetic. They are definitely going to rate like 1-star, 2-star, but they will let it be. They are not going to put the effort of rating something as 4-star, 5-star. So that is the user behavior that is going to be there. Secondly, let's face it, there's going to be very, very sparse data because most of the users are not going to take these actions. Most of the users are not going to add the rating or like or dislike or add to a list, right? So this is going to be very biased data, plus it's going to be sparse data. So even though these explicit engagements are like very, very important, this kind of engagement is very important in any system like Netflix. For big systems, we might definitely want to give like good weightage to this for users. But to keep our design simple, currently we are not going to be considering these explicit engagements, and we are going to be considering only the implicit engagements. And these are the kind of assumptions that we should be calling out in any system design. So what is implicit user engagement? User clicking on a particular media, watching the media, re-watching the media, leaving the media. All of these are implicit actions that are being taken by the user. What metric out of here is actually most important for us? Just think about it. When the user is actually watching, what is most important for us? Pause and think about it and let me know in the comments. Some of you might think that click-through rate is most important. Basically, the number of times the user is clicking. Think about the problem with that. Let's take an example. There is a particular user who clicked on a particular media, watched 10 seconds and then left. Clicked again, watched 10 seconds, left that media. Watched 10 seconds, left that media. So now we have 3 clicks, but that is not a good recommendation because they are just leaving. They are not really watching the entire thing, right? Another user is suppose clicking only once, but watching the entire 3-hour-long movie. This is actually a better recommendation. Here there are 2 more metrics that I can think of, and let's talk about them. One is the percentage of the media watched. So if you have say a 3-hour-long media, then what is the percentage of that media you're watching? So if we were designing say a system like YouTube, I would have actually loved considering this particular metric. Actually, before we move ahead with the discussion, let me share something interesting with you as a YouTuber. So you must have heard that YouTuber gurus recommend YouTubers that all your videos should be of the same length. Suppose I'm creating tutorials of length 1 hour, I should make sure that all my videos are 1 hour long. If I end up creating a 10-minute long or a 15-minute long video, what is going to happen is even if the percentage of the video watched is going to be same, the average view duration is going to go down. So let me explain. YouTube does not consider the percentage of the video watched. They consider only the average view duration. So usually if my videos are say 1 hour long and users tend to watch say only 10% of it, then that 10% is actually more than the 10% of a 10-minute long video, right? So even though the percentage watched is same, the average view duration has now gone down, and that is why YouTube doesn't recommend those videos. So YouTubers are recommended that all your videos should be of similar length. But anyway, so I'm just telling you that is something that, interesting that you should know about. So that they consider average view duration. They do not consider percentage of the video watched. Now in Netflix also, if I consider percentage of the video watched, it doesn't make a lot of sense because say documentary or a particular TV show might be say 30-minute long episode, but a movie might be 3.5 hours long, right? So it doesn't make sense that I always compare percentage of the video watched, because even if you're watching only 10%, you ended up watching a lot more time for a movie instead of the show, right? So what I'm going to be considering in this particular system design is that I want to consider session watch time. So if a user is logged in, what is the total amount of time that user is spending in that particular session? So I'm going to consider even if the user has watched only 2 things, but if they ended up watching for 3 hours, that is good enough. 6 hours is really good compared to if they end up watching 5 things for only 5 minutes, right? So I'm considering session watch time. For non-functional requirements for a system like this, to have good user experience, very low latency is extremely important. Plus, considering the scale of the system, we obviously want high scalability. So for such high scalability, having less latency and very good accuracy actually becomes very challenging. So we will be discussing how to achieve accuracy, taking care of very less latency and very high scalability. Let's now talk about metrics to evaluate our system in more detail. Just like any other system, we are going to have two kinds of metrics, online metrics and offline metrics. Let's talk about them one by one in detail. Online metrics, as the name suggests, is when our system is already live. We are evaluating our system after we have already deployed it into production and it is live, and we are basically evaluating it on our real-time user data. So real-time, whatever our user is taking actions, we are evaluating our system based on that. Usually in online metrics, A/B testing is used. If you do not know about it, let me just quickly tell you about it. So in A/B testing, the users are divided into two groups, say group A and B. In group A, users are going to see recommendations from the current baseline model, and group B users are going to see recommendations from the new model that we want to test. Now we are going to test based on some metric, and we already discussed this. We can consider many metrics, but for online it makes sense out of CTR, percentage of video watched, and session watch time. We are going to be considering session watch time. So we are going to be comparing session watch time for these two groups, group A and group B. Group A, again, users are seeing recommendations from the current baseline model. Group B, users are seeing recommendations from the new model that we want to test. And now based on this monitoring of the session watch time, based on the recommendations, we are going to understand whether we should roll out our new model to all the users or not. Coming to the offline metrics, again as the name suggests, it is when our model is not live, it is offline, right? So we are evaluating our model before it has gone into production. So we are obviously not evaluating based on real data. Based on what data will we be able to evaluate our model? Because it is not gone into production, it is not live, right? So we will be using some historical data. So based on past user actions that user has taken, we are going to evaluate our model. Now here there are two things that we should know about, precision and recall, and the difference between them is actually very interesting, very subtle. In this context, let me quickly tell you about them. Precision is that out of the total number of items that we recommended, how many were relevant? What is relevant over here? See, in historical data, we already know that these items or these media, these movies or shows are user liked, right? So those are the relevant items for that particular user. So precision is about correctness. Out of the total items that we recommended, how many did the user like? So the formula is going to be number of relevant items recommended upon total number of items recommended. Recall, on the other hand, is about out of all the relevant items for that user, out of all the items that our user would have liked, how many did we recommend? So recall is about making sure that we are not missing any good items that our user would have liked. So recall is the formula going to be the total number of relevant items that we recommended upon total number of relevant items. So precision is about our model being correct, and recall is about our model not missing some good media. Now we are designing for millions of users, right? And we want to take mean of all the recommendations for all the users. So we are going to be considering mean average precision and mean average recall, MAP and MAR. And if we want to maintain a balance between these two, we can take F1 score, which is the harmonic mean between these two. Let's now quickly do some capacity estimation. So this is obviously rough capacity estimation. That is what capacity estimation means. We are going to get started with discussing the assumptions that I am making. So I am assuming there are 500 million users, and each user is supposed going to make 100 interactions per day per user. Then we are probably going to have 20 recommendations per user per day. Then we can have probably the metadata that we are going to store in 1 KB. Now this metadata is like basically for every video, right? And we can have suppose 100K videos in our Netflix catalog as of now. So these are the assumptions that I am making. Also, other than this, I will need to embed my user data and my video data, right? So I am probably going to take 512 bytes to store the embeddings. So now that I have talked about the assumptions, let's do some quick storage calculations. For storage, I am going to be first considering the user interactions. So as we discussed, there are 500 million users. We have 100 interactions per day, and each of that is going to take 1 KB. So this is going to be it is going to be 50 TB per day. And suppose I want to calculate for 1 month, so 30-day retention. So I am going to probably have 50 TB into 30. So that is going to be roughly 1.5 petabytes. So this is the storage just for the user interactions. We are going to need some storage for the embeddings as well. So for that we are going to be embedding users, right? So for users there are 500 million users, and for each of them again if I am embedding to 5 or 2 bytes, so this is going to be roughly 256 GB. And similarly for video embeddings I have 100k videos, and again each of them I am going to be storing in 5 and 2 bytes. So this is a much smaller number, which is basically just 50 MB. Other than the user interactions and the embeddings, we are also going to be needing some space to store obviously the recommendation output, right? So let's consider the recommendation storage. For this we have 500 million users, and for each user we were doing 20 recommendations, right? So suppose each recommendation is taking 1 KB. So this is roughly 10 TB per day. And again if I consider for 30 days, this is going to be roughly 300 TB. But usually we will probably have like a smaller storage for recommendation. We don't need to store for 30 days. Suppose we are storing in 7 days cache, right? So we can probably have 10 TB into 7. So that is going to be equivalent to 70 TB. So this is the storage that I am going to be needing for the recommendations. If we see over here, the maximum storage that I need is to store the user interactions, which is 1.5 petabytes. Again, it is up to discussion. I have taken for 30 days. We could be storing for 6 months, 1 year, right, depending on our trade-offs. Other than the storage, we should also be talking about the throughput or the bandwidth calculation. So I'm going to keep it pretty simple as of now, and we are probably going to take just suppose 100 requests per second. And if I have that, and every request is basically going to have 20 recommendations or 1 KB, so I'm just going to need a throughput of 100 Mbps, right? So that's it. I'm going to keep things very simple as of now. If you have any recommendations for capacity estimation, let me know. Anything up for discussion. Let's finally get started with our high-level system architecture. In recommendation system, usually the approach is that we are going to have multi-stage architecture. The name sounds very fancy, but it is very simple if you think about it. We are essentially dividing our architecture into multiple stages. In our case, 2 stages or 2 steps. It is very reasonable, understandable. It's very simple. Think about it. When we recommend videos to our user, do we just select the videos? We are not just selecting, we are also ordering the videos and then sending, right? So on a high level, this is the approach. So let me actually show it to you. So what I'm going to do is I'm going to add one model, and I'm going to be naming it candidate generation model. From the name, can you guess what this is doing? As the name suggests, candidate generation model, right? According to our capacity estimation, we have 100k videos or 100k items media in our Netflix. What this candidate generation model is going to be responsible for is that it is going to find top 1000 or top 100 candidates that can be recommended to our user. Now I know you must be thinking that in our capacity estimation we had taken 20 recommendations per user per day. Then why am I saying 100 or 1000? Let's take 100 for now. So if I have 100k videos that can be recommended, I'm going to find the top 100 candidates that could be recommended. So these are just candidates. These are not the final recommendations. And then I'm going to have another model. So this is essentially my second stage, and I'm going to call it ranking model. And it is this model who will be responsible for finding the top 20 recommendations. It could be any top K recommendations. In our case, it is top 20, and rank them in a particular model. From the name, I know that ranking model sounds like we should only be ranking. We should not be finding the top K selection. Like we should not be doing that. But it's okay. In our system design, that's what I'm doing. So this candidate generation model is going to be finding the top 100 candidates out of the 100k videos that we have. And then I am going to send those 100 candidates to our ranking model. Our ranking model is then going to select the top 20 recommendations and recommend them to our user. Let's talk a bit more about why this architecture is so beautiful. Just think about it. See, we already talked about precision versus recall, right? So my question to you right now is that our candidate generation model, what do you think it is going to focus on? High recall or high precision? If you forgot about it, timestamps are there. You can always watch the video again. Do not worry. Our candidate generation model is going to focus on high recall because it is selecting the candidates. So this is the model that will be responsible to make sure that we do not miss any recommendations. So out of all the relevant videos or media that our user would have liked, candidate generation model is going to make sure that we have all of those relevant media items in our recommendations, in our candidates. Then what our ranking model is going to do? Our ranking model is going to focus on, again think about it, our ranking model is going to focus on, yes, that is why it is so beautiful, it is going to focus on high precision. So it is going to focus on making sure that we have really relevant recommendations. Recommend relevant media. And that is the beauty of this. Just think about it. Our ranking model is dealing with how many videos? It is dealing with only 100 candidates. So because of which our ranking model can actually be complex. It can be very heavy and it could actually be slow also because it is dealing with very less number of media or items, right? And because of which in our system, what all things can be achieved? Think about it. So all the requirements we will be able to fulfill because of this architecture. Why? Because we can have good scalability. See, our candidate generation model is just doing the short listing. It is narrowing down the candidates for us. And then ranking model is the one that is doing the heavy part. So, and it is not dealing with so many videos, because of which we are able to achieve scalability. Plus, we also have modularity. Why? Because there are two different models taking care of two different things. We basically have better flexibility, and this is so beautiful. For more system design fields, let's add more components to this. By the way, if you're wondering where am I designing all of this, so I'm designing on Daxtop.com, which is our in-house product. So we have two products and we have not launched them officially because we are still working on them. But Educosys students are actually already using this. So you can check out all the elements are there that you need for high-level system design. Databases, we have all kinds of databases. We have vector databases also. You can add your own custom DB as well. AWS, all the elements are there. Azure, GCP, so you can explore it. It is pretty awesome. I'm going to share the link so you can actually create a copy of this and you can add your own notes and you can play around and you can create your own designs, right? So you can share that this is what I'm working on. You can also comment on others' designs and then discuss that what could be done, what could not be done. So this is a pretty cool thing that we have worked on. Check it out and let me know if you like it. But okay, moving on. So who is going to be sending the request to this candidate generation model? So we are obviously going to have a server, right? So let me just quickly add that. And I'm going to call this, suppose, recommendation service. So our user is the one who is going to be sending the request, of course. And obviously for scalability, we can add load balancers, API gateways, right? So not going into a lot of detail, but you get the point. So via the load balancer, we are going to send the request to recommendation service, which is then going to be sending the request to our candidate model. Let's discuss these models in detail now. Coming to the candidate generation model. See, there are many techniques that are possible to generate the candidates, and I want to discuss three techniques over here. The first one is called collaborative filtering, and let me explain it to you in very simple terms. Suppose I am the user for which our system is supposed to recommend the media. Now what our model is going to do is, it is going to find the users that are similar to me. Now suppose you and I have similar watch history, we have watched similar videos in the past. So our model is going to recommend me the items that you are watching. So based on the similar users, I am going to be recommended the videos, right? So that is called user-based collaborative filtering. If you think about it, all that the model has to do is, the main focus is on finding the similar users, right? So this is a nearest neighborhood problem. We could be using KNN or we could be using matrix factorization and so on. The problem over here is, the edge case essentially is the cold start problem. To be able to find the nearest users, there have to be enough users, right? So if there are not enough users, if the system is new, then that is going to be a problem. So that is one edge case to consider, that there have to be enough users. The second technique that could be used is content filtering, content-based filtering. And here our model is not going to be depending on the other users. So we won't have the cold start problem of having enough users. So what our model is going to do over here is going to see the items that I have watched previously, and based on that I am going to be recommended similar items. Again, here the edge case is going to be that enough number of items should be there, right? So cold start problem is still there, but for items and not for users, right? So the third thing that we could do is, third technique is embedding based similarity. Here our model is going to embed the users as well as the items that we have, and we can do cosine similarity, or we can do any similarity search between them. So we can do word to vec, we are basically using deep learning over here, right? Again, the problem over here is going to be that we need enough data, enough computation to be able to have something as complex as this, but this will be able to understand very, very complex patterns. Now, since these have their own pros and cons, and there are many other approaches as well, we could also have a hybrid approach, where what we are going to do is we are going to have these generators, these are the multiple generators, and they are going to generate their own candidates, okay, their own list. Suppose this generates 100 candidates, this generates 100 candidates, and this generates 100 candidates. Now we are just going to merge these candidates and generate like a final 100 candidates. If there are any duplicates, we are going to deduplicate it and generate the final 100 candidates and send that to the ranking model. So we could use a hybrid approach over here. For ranking model, we could set up our own deep neural networks, or we could use models like XGBoost, keeping things simple right now. It's finally time to discuss data collection and data storage in detail. Let's get started with our nice little user over here. So we have to store information related to user, correct? So I am going to have a lot of metadata like age, gender and all. Maybe I can use SQL DB for that. So any SQL DB should be okay. MySQL, Postgres. Let's just add Postgres over here. And let me just quickly write the data that we are going to be storing. So we can store age, gender, location. So in location, I mean country and probably state. Because I am storing state now that I remember, language also makes a lot of sense for Netflix, right? Other than this, I could also store maybe, because we are considering session time, right? So I could store average session time, that would make sense. What else can I store? Maybe genre preference. I'm sure there are more things, but you get the point. So these are the core important things that I would be storing. See, these are the metadata things that we have stored for the user, but user is making a lot of interactions in real time, right? So it's the user is clicking, replaying, pausing and all of this. How do we store those collections and where do we store those collections? Because it's a very high volume data and it is real time, it makes sense to add a streaming pipeline. So I'm going to add Kafka. Let me just do that. I'm just writing pub sub so you can understand that I'm talking about Kafka. And all these real-time interactions that I am streaming, I basically want to store them somewhere, right? So I need a database that can take high throughput, a lot of write, plus something that is horizontally scalable because there's going to be a lot of data. So the correct fit is, think about it and let me know if you thought the same. So I'm going to be using Cassandra over here. So this is because it is horizontally scalable, it has high write throughput and it would be a great fit over here. So this is where I'm going to be storing all the real-time interaction data like clicks, plays, pauses, replay and so on, right? So this is the real-time interaction data. This is the data for the user that is in general there, right? Just like we have data for the user, we will also have metadata for our videos, right? We will obviously need our videos also to be stored. So video storage is going to be separate in S3. Currently, I am talking about video metadata. So again, for video metadata, I can use SQL DB. I am again going to add Postgres itself. So let me just quickly write it. In video metadata, we are going to store things like suppose release date, suppose if it is movie then duration, if it is a show then maybe number of episodes and all of that. We can also have content type over here which is going to tell us whether it is movie or not, and then we can also have things like actors, actresses and all of that. Another important thing obviously will be genre. Now see, these things like the age, gender, location, as well as the release date and all of this. So the metadata for the user as well as for the video metadata, it is not something that is going to be updated very frequently. Okay, so this is not real time data that I am talking about. So this data that we have, the user metadata as well as the video metadata, this is not being updated real time like the user interaction data, right? So this data, the user metadata, video metadata is not being updated like the user interaction data, right? This is real time. So we can think of it like this is going to be updated in patches. We can have like hourly or daily updates over here. So this is not something that is being updated very frequently. We could also want to store all the logs somewhere. So it could be either from the Kafka, so all the events that we are streaming, or it could also be basically our model logs or training logs or anything. So for that, I could use blob storage like S3. I'm adding another S3 just to show you that, okay, the videos are probably saved over here. So videos, video metadata, all of this information is going to be used by our models, not just by our candidate generation model, but also by our ranking model to be able to generate good results. So I'm just writing down that our candidate generation model is going to give the candidates. So in our case, we are going to get 100 candidate media or items. Also, we are talking about machine learning. We obviously need embeddings. We are going to do a lot of similarity search and all of this, right? So for the video metadata, the user metadata, video metadata, as well as videos, it makes sense to embed them and store in a vector DB. So probably we can store in a vector DB like Pinecone. So let me just quickly add that as well. Again, this can be done in batches. So this is the overall system design. I have made a few changes and let me just quickly walk you through them. The first obvious change is that I had created the databases with this user, but I hope you did not get confused that this is the front end user, right? So the right thing would be to create the databases on the right side of the load balancer. So for further clarity, I've created one user service. This is the service that will be responsible for dealing with the user data. I've also created one content management service. This is where our Netflix people are going to add the content, and this is the service that will be responsible for dealing with the video metadata and the video data. I've also created one data aggregator service that will help us add the real-time interaction data into Cassandra. Let's just do a quick walkthrough of the entire flow. So once our user logs in, so user service will deal with that. Let's say that our user has logged in. Now, obviously, the recommendation request is going to come to the recommendation service. Now, there are different ways of dealing with it, okay? And you should know that either we can do this in real time or we could also do it in batches. Like, for example, we could also do a hybrid approach. Suppose for popular videos or trending videos, our models could find them in batches and cache the results, and our recommendation service could like respond to that. Or we could do this real time as the request comes for the recommendation. Our recommendation service is going to send the request to these models and get the response. Also, these models are going to use the data that are present in the Cassandra as well as the embedded version of the user metadata, the video metadata and all of this. So this is our vector database that I have drawn over here. I hope the entire system design is completely clear. If you have any questions or if you would design this any other way, I would love to discuss the pros and cons with you in the comment section. So please do that, and I am sure that it will be a very healthy discussion. Another very important point that we should definitely be discussing is the fact that there will be a lot more number of not watched videos or items compared to the watched videos or items. So there is an imbalance, right? Because obviously there's out of the 20 recommendations, like there will be a lot lesser number of videos that will be watched. So we have to maintain a balance between this so that our learning is better. So because of this reason, we will have to do downsampling of these negatives of the not watched videos to make sure that there is balance and the training is done properly so that learning is better. By the way, created these notes and this is present in the description for completely free. I have been creating notes for all the videos that are covered in the machine learning playlist. So check them out, and if you want to discuss or if you have any feedback for the notes, just let me know. This is completely free. And this brings us to the end of the video. There is actually very less content that is available for ML system design, and I am creating this entire series. So the other series where I am covering the projects, Gen AI, ML basics, that will continue, but I am creating this other series focused on ML system design interview rounds. So I hope you are liking it. Like in the next ones, we are going to cover more topics. I plan to cover all the important ones that are there for interviews, like ad-click prediction and all of them. By the way, if you have watched till here and if you are interested in watching the rest of the videos, I don't see a reason of why you're not subscribing. I mean, you do want to support me, right? You can see that a lot of effort went behind this, right? Then why are you not supporting me? Please subscribe, hit that notification bell icon, share with your friends. Please do it. It will mean a lot to me. See you next time. Bye.